Welcome. This is the first lecture for CEE 4300. This is hydrology. Today we're going to cover talking about a whole slew of things. We're going to lecture one. We've got a number of learning objectives, and the way that this flipped class thing is going to go is that we'll do about 10 minutes of lecture, pause. You'll do something on your own. You'll watch the next 10-minute lecture video, pause, etc. So there might be 3 or 4 videos for each class period, and you'll watch them, and before you come into class, this is your homework, and you'll come in and then we'll get to work doing some activities. So the reading for this class was page 160 to about 187, 188, and the reading for next class will be 187 or 188 to about 197, right? So make sure that you do those, and during this class period I'll ask you actually to step away for a little bit and read a chunk of the book and jot down some notes, and you'll want to bring those to class. One other important thing about this is that there will be certain times when I'll ask you to write something down, and because we'll talk about it in class, and I'll want you to do that. You'll have to do it and be expected to be called on, or for me to check that to make sure that you've done it. So the learning objectives for today is we're going to talk about the importance of statistics in hydrology. We're going to define return period and its relationship to risk. We'll review the important statistics that we use in hydrology, and then we'll also talk about how we can use probability and statistics to answer important questions in hydrology. And so one other reminder before we get started here is that you've got a course set of notes, and you want to use that note pack, and these slides and the lecture here will correspond exactly to that note pack, and you'll want to jot down the notes inside of that. Okay, so let's begin. So hydrology, right, it's a physical science. It's the study of water, right? Hydro and ology. And as a science, right, there's a lot of really interesting science questions. So, where does water go? What processes govern the fluxes of water? How are the atmosphere, the land surface coupled via water? And so here you can see a nice image by the USGS, right? We've got evaporation from the oceans up into the atmosphere, some condensation, and then precipitation onto the terrestrial part of our planet where we live, right? And that precipitation might come as snow, rainfall. If it comes as rainfall, it might run off, it might land on some leaves or get soaked up by plants and evapotranspire back into the atmosphere. It might get stored as snow or fresh water. It might infiltrate into the ground, right, and come out as groundwater flow. And many of these fluxes, kind of either recycle the water over the land surface or send it slowly back towards the oceans, right, through surface runoff. And so for science, right, this is just a field of awesome questions, right? How do all these things take place? What are the governing mechanisms, right? And there's lots to know. But you're taking this class not as a science class, but as an engineering class, right? And so we want to know, how does this apply to engineering, right? And so to begin, right, hydrology, it's very important in engineering, and we'll talk about why here in a second, right? But in order to do that, we want to couch things kind of in the language of engineering, and that's why these first 2 lectures we're going to talk about probability and statistics, right? So in engineering, hydrology is thought of more kind of as a game of frequency. Why is that? Well, let's look at some engineering questions we might ask. So the first one might be, what is the probability of 2 100-year droughts in a row, right? So here we're talking about 2 really extreme events happening right next to each other, this year and next year. What's the chance of that happening, right? What's the extent of the 100-year flood for FEMA mapping? So a 100-year flood would be a really large flood, the flood that happens on average once every 100 years. And, how far does the river spread out? What's the extent of inundation when that big flood happens? Because, for FEMA, they want to know that, because it can define what we call is this thing called a floodplain, and it could change, who and how things can be built in that area. In this state, we have some administrative code called NR 151 that requires the management of 1 and 2 year storm events. So here we're talking about, you know, the largest rainfall event that happens on average every 1 or 2 years. We need to regulate that. We need to design systems to prevent that from just kind of flying off the landscape. And so for in this class, we'll learn about, you know, we want to know how big does a pond have to be. So if you think about the pond out near the new McDonald's or the Walmart there, right, that those things were put in place to manage exactly these types of events, right? Might want to know what's the probability of running out of water supply this year. So just like probability of droughts, we might be concerned that we don't have enough water in our reservoir. And you can think about current events out on the West Coast, the severe droughts that are happening out there now in 2015. You can think about other times in the past or times that are going to happen in the future. You know, and lastly, this is a hard engineering type design thing, you know, designing a culvert under a roadway, right? So here, FHWA, it requires that culverts, they have to pass large storm events so that the interstate systems don't fail, right? So we need to know, well, how big is this event? And then once we know how much water is coming through, we can design the size of the culvert, right? So how do we couch this in terms of planning and design? Well, let's think about each of these things we kind of went over. So some planning aspects might be drought management, right, where we're asking, you know, how often do these droughts happen? What's the probability of it happening? And we might be able to help plan for drought, right? Best management practice design kind of falls under these design aspects, right? So under best management practice design, we're talking about designing infrastructure or other structures to basically deal with water quality and quantity control. Sizing a culvert is very definitely a design aspect, right? There might be a little bit of planning going into that, but we're really talking about sizing a structure again. Now, floodplain mapping and planning, I would say, is more under the planning aspects, but it also does deal with design to some extent. Design and operation of a reservoir can fall under both planning and design. Right, we might be talking about, well, how big should this reservoir be? We also might be talking about, well, when do we have to build the next one, and how big does that one have to be? How do we manage the day-to-day water use, right? So it could be kind of planning, or it could be designing the actual structure. And then lastly, we have things like designing a bridge, right? Designing bridge structures. How high should that thing be up off the river? Should it be designed to be overtopped? Or should it never overtop, right? These are kind of critical questions that we need to answer in engineering. Okay, so in order to do this, we need to talk about the frequency of these events, you know, or basically the probability, right? And then the statistics associated with them. So for the next 4 minutes, we're going to talk about that. Then you're going to take a little break and jot down some notes, do a little thinking exercise, and then we'll come back and continue the lecture. So frequency describes, right, how often an event, in this case we'll denote it as x sub I, takes place, right, in a large number of trials. That's what frequency does, right? And so mathematically we define this as the probability of an event is equal to the number of occurrences, or its frequency, divided by the total number of trials, right? And so we can see that definition there mathematically on the screen. And this is where n sub I is the number of occurrences of an event, right, x sub I, in n trials. And n sub I over n is also, we sometimes refer to that as the relative frequency of x, right? And the relative frequency is the probability after a large number of events, right? And the actual probability is the limit toward infinite events. Okay. So from the laws of probability, and those of you that are taking statistics or have taken it, you've probably seen some of this, right? The probability of an individual event has got to range between not happening or happening, right? Completely happening, right? So it's got to take a value between 0 and 1, right? And we know that when we sum up all the probabilities, right, of these events, it's got to sum to 1, right? It's got to sum to 1. Where big N is the possible outcomes, right? And so, so that's important, right? That's important. And kind of the next piece that goes along with these kind of two basic tenets of probability, these laws of probability, or probability of independent events, right? So independent events are events which do not influence one another. If they did, we would then need to use something that's called conditional probabilities, right? So what is an independent event? Well, you could think of it as something like flipping a fair coin, rolling 2 dice, drawing a card from 2 different decks, right? Things that don't influence each other. I could roll 1 dice and I could roll another dice. And, because I rolled a 1 on 1 doesn't mean that it's going to change what happens on the other one, that I'm more likely to get a 1 or a 4 or whatever on the other dice, right? They're independent events. So one thing I want you to jot down a few notes about, and we'll talk about in class, is rain. Rain, precipitation events, storms. What do you think? Do you think these are independent events? Do you think it's okay to treat them as independent events? Yes, no? Comments, concerns on that? I want you to think about that for next class when we meet in the lecture. Okay, so the last piece we're going to cover here for one more minute is talking about what we call continuous and discrete variables. So continuous variables, by definition, they can take any value. And what do we mean by that? It basically forms this thing that we call a smooth distribution. So what are some examples of that? Well, I'm going to put some things up here and I'm going to want you to categorize them as either continuous or discrete variables. So what's a discrete variable? Well, it takes a set value from a domain of discrete values, right? So again, what are some of these things? You might be thinking about that right now, so you can think about it. So here, I'm going to put some of these up, and then I'm going to let you categorize them before you watch the next video. So we've got height, right? We've got the height of the different SpongeBob characters here. We've got temperature, body temperature, air temperature, stream flow, right? Coin flips. We've got precipitation, and we've got floods, right? So think about it. This lecture is gonna end here, and before you watch the next lecture, write down where you think in your notes these things fall under continuous or discrete variables, and we'll talk about that in our next class lecture.